Okay, Assalamualaikum. And okay, for now we will look at high derivative. Okay, so like y equal to fx is differentiable function, and then the derivative of f can be written as such. Okay, this is the first derivative. That means the first time you differentiate. The second time you differentiate will be the second derivative. The third time will be the third derivative, and it goes on until n derivative. Okay, and also please note that dy dx power of 2 here like this does not equal to this one. Okay, because dy dx in bracket power of 2 is actually the same as we say a power of 2. Okay, that means this function power of 2, but this notation means second derivative. It is not the same, totally not the same. Okay, for example, let's say we have here find dy dx, d squared y dx squared, and the third derivative if we have y equal to 8x squared minus x power of 4 plus 3x. So dy dx is the first derivative, so therefore we differentiate this function y, we will have differentiate 8x squared is 16x. Differentiate at negative x power of 4 will be negative 4x cubed. Okay, differentiate 3x is actually 3. Okay, you need to be quick here. Okay, and then next we want to find the second derivative, means we differentiate the first derivative, d dx differentiate dy dx. Okay, and hence the differentiate 16x will be 16, negative 4x cubed is negative 12x squared, and differentiate constant will be equal to 0. Okay, the third derivative will be differentiate again, but we differentiate the second derivative. Okay, which means differentiate 16 is constant, so that's why we don't have here because it is 0. Differentiate negative 12x squared is negative 24x. Okay, that's for the first one. Okay, let's look at the second one. We have here, if y equal to x plus 2 ln root x, we need to show that x d squared y dx squared plus dy dx minus 1 equal to 0. Okay, let's determine the dy dx and the second derivative. Okay, first we have y equal to x plus 2 ln. Okay, to make it easier, change it into index, right? Okay, change it to index form first. Okay, next dy dx is differentiate x is equal to 1. Okay, constant. How we differentiate ln? As I mentioned over and over again, rewrite the function first, and then only you differentiate it. So half x power of negative half, which can also be written as 1 plus 2 times 1 over 2. X power negative half would be, here is x, and equal to 1 plus 1 over x, which is the same as 1 plus 1, x power of negative 1. And then the next one is d squared y dx squared. Differentiate this dy dx. So differentiate 1 is 0, differentiate x power of negative 1 is negative x power of negative 2. So this one is the same as negative 1 over x squared. Okay, before we move on, I think some of you might have a little bit confusion on how I simplified it into x. Okay, please recall index, law of index. Right now we have x power of negative half over x power of half. It can also be written as x power of negative half minus half, right? So it is x power of negative 1, which is the same as 1 over x. Okay. Okay. So let's continue on. We need to substitute dy dx and d squared y dx squared in this equation. So we have x times negative 1 over x squared plus 1 plus 1 over x minus 1. this one is equal to, okay, this one is left hand side, okay, equal to this, okay, it doesn't fit there. X is, we have here negative 1 over x plus 1 over x minus 1, so it is equal to 0, right hand side. Therefore, we have shown it. Okay. Okay, let's do the last one. Given that y equal to exponent to x ln x, calculate d squared y dx squared. Okay, as you can see here, we need to apply product rule. This is u and this is v. Okay, because this is a multiplication of two different function. Okay, ada dua function yang berbeza kat sini. Okay, hasil darab dua fungsi. So, u is equal to exponent to x. U prime is equal to 2 exponent to x. V is ln x, which means v prime is 1 over x. Okay, the first derivative is dy dx is equal to u prime v plus uv prime, which is 2 exponent to x darab dengan apa? V ln x. And then plus u. U is actually exponent to x darab dengan 1 per x, which can also be written as this 1 over x. Okay. Allah. Okay, this is dy dx. So, we need to do the second derivative, right? So, as you can see, this one, we still need to use product rule. But, hey, we have a shortcut here. We don't have to do it. Why? Because it is almost the same as this function. Except that, we have another constant at front. So, actually, you just need to solve this part only. Where you need to use quotient rule again here. Here is quotient rule. This one we use product rule. Okay, quotient rule, which means we have u equal to exponent to x. U prime is equal to 2 exponent to x. V is equal to x. V prime is equal to 1. Therefore, d squared y dx squared is actually equal to 2. This one is the constant here. Okay, we want to solve this part first. Okay, so 2, open the bracket. This is the dy dx. This one is the dy dx after we have differentiate exponent to x times ln x. But right now we have 2 exponent to x ln x. We just need to rewrite 2 outside the bracket. Okay. Copy the answer that we have gotten for dy dx. Plus exponent to x over x. Okay, plus here we need to apply the quotient rule, which is u prime v minus uv prime over v squared. Okay, u prime 2 exponent to x, and then v is equal to x. Next, minus u times v prime 1 divided by x squared. Okay, that's it. Even if you don't want to simplify, this answer is already correct. You can leave your answer like this. Okay. Or if you want to make it much more nicer, it should be like this then. 4 exponent to x ln x plus 2 exponent to x over x. Okay, that's it for high derivative. Okay, make sure you polish your differentiation for all type of functions, and also product rule and also quotient rule. Okay, thank you. Assalamualaikum.